slew of slides today. I have this is a video game written in RPG Maker MV, which the RPG Maker engine used to be in Ruby, and before that it was strictly point and click, and now it's moved to HTML5 and JavaScript. So this game is HTML, CSS, and JavaScript. And I've added some of my own JavaScript on top of that for WebSocket purposes, which we'll go into in a bit. So this is my character walking around a bit, and I'm going to try to take my character into the laboratory. The lair of the node botanist. The lab. My lab. Okay, yeah, whatever. But the lab wants ID. But you know it's me, I mean, come on. Well, it's my security protocol, apparently. So, alright. Let me find my key here. Where did I put that key? Here's the key. So the key... So I'm going to activate the ID system, and the way I'm going to do that is... Camera. So, this is an ESP8266 microcontroller. It connects to the internet. It is running a very tiny JavaScript engine called Espruino. So it's running JavaScript on the chip. And right here I've got a keypad. And it's pre-programmed with a code that when I enter the code, it should send it to a WebSocket that sends it to the game that says, yes, this is me. So let me plug this in. Here's a cable. Let it connect to the internet a bit. Let me pull up the code while it's connecting. Looks like it may have already connected, actually. So let's go back to the game and see if that works. Not quite. All right. Let me make absolutely sure that this is the server's running. Fun. Don't you love it when demos do this? So I'm going to connect it to the computer and do a little bit of debugging. So while I'm talking about that, I'm going to also talk about how this is even possible. So it used to be you ran Node on your computer, and it would talk through the serial port on your computer to an Arduino Uno or a Raspberry Pi or whatever. And then eventually we had Linux machines that could run on them, and they had GPIO. Now we have these little tiny JavaScript engines that can run on very small chips right off the bat. So I'm going to check that my chip is working. Check the Wi-Fi. Get IP. Make sure it's connected to my access point. That would be why. So. So, as JavaScript engines have been getting smaller and smaller, we've been able to run native JavaScript code on chips like the ESP8266 and ESP32, which you can see here. And this puts robotics into a lot more hands, a lot more web developers. Because once you have the very basics of electronics down, you can start to program your own robots in JavaScript. You don't necessarily need to learn any C in order to get started. So, let's try one more time. Oh, aha. That's why. It helps if you have correct syntax from time to time. Are you kidding me? This will kill me today. And I will change the password to my Wi-Fi after this in case any of you are getting any funny ideas. Aha! Okay, good. There we go. Alright, so now it's reconnecting to the internet. My router is still running. There we are. Okay, so now that we're actually connected to the internet, I'm going to go back to my game. I'm going to enter my passcode one more time. Yay! Okay. Okay, so the security system begrudgingly informs me that, I've identified myself and I can get in. I'll walk in. Ooh. As you can tell, I'm not a game designer. My maps are quite, hello, come on. Of course everything works in the night before when I read through this. So now, you know what? Benefit, I can show y'all the, that's why, action button, okay. Running back in the game. So, why is a library the main entrance to my laboratory? And this is true both in the game and real life. When you walk into my lab at home, there are giant bookshelves over both sides of the wall. And people ask, like, why so much books, why so much documentation, and why is this even necessary? But when you think about it, when was the last time you used a library without documentation? And you were forced to do that, how much of your hair did you tear out? Because I tore out a lot of my hair the last time I had to use an undocumented library. Documentation and knowledge sharing is the key to really everything, but especially Node Robotics. Everything you ever use in Node Robotics has been worked on by lots of people in their free time who are doing this for the love of it, not for profit or anything like that. So the library represents really not just my own knowledge, but the communal knowledge that we all benefit from. Open source work thrives on documentation and dies without it, and that's why a library is a suitable first room for the lab. There are 3 rooms from here, and so one is the engine room, one is the social room, and one is the tools room. And the first room we're going to check out is the engine room. 1 and 2. Here's the one on the left. Great. So this seems a little underwhelming. There's only 3 little engines in here, 3 little flames. But the possibilities become endless with this diversity of JavaScript engines that exist in the world. JerryScript and IoT.js are a great example. Esperino, which is what I use on most of my demos today, and Ducktape, which is an up-and-coming JS interpreter, make possibilities that seem so far out of reach, especially because NodeBots is such a new community. It makes them possible, and it puts more robotics into the hands of web developers, which is a personal goal of mine. If you see something and you want to build it, my goal is to be like, yes, we can help you build this in Node, let's do it. Esperino ran on the key to the lab, and on many of my examples today, as I mentioned. And because we're taking JavaScript to its limits, and because we're daring to make engines smaller and trying to put them in more places, this is how we move forward as a community, and not just from a robotics perspective. JavaScript and Node benefit from the robotics community just as much as the robotics community benefits from Node. It's a symbiotic relationship where we learn more about optimization, making things smaller, and this benefits everybody. So we're going to take a look at the name tag here, which relies on another demo that I'm going to get rebooted here. So, another example of how Node Robotics has come very, very far is the Tussle 2, which is this microcontroller right here, this square one. So it runs a version of Linux that is then abstracted out so that you can use command line interface to interact with it instead of having to know Linux. So I'm going to plug this in. And what I've got here is this LCD is communicating via the USB port on the Tessel using a serial connection. And then I've got some APA 102 lights. And so they're individually addressable RGB LEDs. Now the reason I'm booting this up, let me make sure that still has an IP. It does, good. So this also hosts a small web server. When it receives an event from some serverless functions I'm running on AWS Lambda, it sends information to the name tag. I was able to do this just as you would in Node, http.request, http.onRequest, instead of having to worry about if anybody else has coded a WebSocket in C, I'm sorry and I feel your pain. Programming them in Node is so much easier. So, okay, it's booted. So I'm going to run the demo. Okay, I'm going to close this. Oh, I'm not going to close that. I want that to continue running. That's the tab I want. Live coding, it's great, right? Okay. So what the TesselBot does is I have a bunch of if this then that scripts, IFTTT, watching Twitter, Twitch, and GitHub, and then I have an IO pipe hook. IO pipe is where I work. We monitor AWS Lambda functions. So when I get those events, it calls webhooks, which are running on serverless functions, which then store them in a DynamoDB. The Tessel makes a request to another serverless function, which empties out the DynamoDB and sends all the events down. The Tessel then displays them for 5 seconds at a time. I call it my social bot, because when I tweet, it says Node Botanist just tweeted. When I push to a GitHub repo, it says Node Botanist just pushed something to a GitHub repo. Just mentioned on Twitter, just gained a new Twitch follower. All of these things. So, let me make sure it's going. Come on, you can do it. Yes. Yes. No! So close. The serial port has been finicky ever since, of course, this morning. You rehearse and rehearse and rehearse. So I'm going to list LAN. No, I just want local area network. I don't want. Let me make sure it's connected. So the Tessel is it's another community project. So it started with the Tessel one. Okay, good, it does connect to the internet. So now I'm going to do something like this. Plug it into just power. And you're going to think, how is that going to help my connection? But you'll find out momentarily. So Tessel started out with the Tessel one, and it was good, and it had a lot of capabilities with Node, but one of its main problems was the cost. It was $100, and so that that made it very inaccessible to, especially folks just trying to get started in the hobby. You don't necessarily want to delve $100 into what might be something you end up not being interested in. The Tessel 2, however, is $40 and much more accessible, and the documentation is really nice. It also has USB ports, which the first Tessel didn't have, and it has Johnny 5 support. So if any of y'all have done NodeBots with Johnny 5, you can use the same APIs on the Tessel too. So now I'm going to run this again. Is it still booting? No, it's booted. It just does not want to work today. Alright. We're going to continue. So the name tag. What I do have here, and I'll show you the code for this, actually. That's probably a good place to start. Let me make this bigger. switch you all can see. So, as I mentioned before, Esprino is a JavaScript engine, so this should look very familiar. For instance, setting timeouts is, that explains why that went wonky. That should be that. So timeouts, same thing. You've got your callback structure, you've got an evented structure, you have all of the things that make JavaScript easier for robotics. For instance, creating a server like this on a C robot is closer to 58 lines of code, I think I got it down to, and that was with some unscrupulous formatting. And so now we can have http.createServer that runs on a robot. This is huge as compared to even 2 years ago, where the only way to go about doing that was either running a full machine that had Linux, which could be either cost prohibitive or size prohibitive. For instance, with this, compare this chip to the size of a Raspberry Pi, like a regular Raspberry Pi. The Raspberry Pi Zero W does have a similar footprint, but even then, you can get smaller and smaller and smaller with these machines, but still have the capability to use JavaScript. And that's where these engines really start to shine. So all I'm doing is setting up my screen, and I tell it to write my name and my Twitter handle and my job. And then if the Tesla boots during this demo, if not, I will get it booting during the day and you can come see it. Every time the Tesla gets an event, it will get a color from the Tesla and then put a little square at the top to match the color of the event. So the social bot and the name tag are synced up. I have basically a botnet that for now does nothing malicious or evil or in any way, shape, or form nefarious. Right now, it just shows off Twitter. Hopefully, I will continue to follow Raquel Velez's #1 rule of node bots, which is do no harm. So, as the authenticator, I'll show you a little bit of the code here as well. Again, just setting up Wi-Fi connection is just calling Wi-Fi Connect with a SSID, a password, and a callback, and that's how I got the IP address. Success LED and key press LED, that's because I had to debounce the keypad, and so I wanted to know when I was pushing a button, and so that was what those LEDs were for. And then the keypad I use is I'm actually running a little shorter on time than I thought, so I'm going to continue onward with my content. So, the next room you're going to explore is the tools room. So, in order to complete any task, really, one needs the correct tools. Hardware tools, however, can be very finicky and complicated and expensive. But me and people like me are working very hard to change that. So we're going to take a look at a couple of examples. I'm actually going to cut it down to one due to time. What I'm going to show you is the waveforms program. I'm going to open that up. And hopefully, unlike rehearsal, this will not crash my computer. Considering how well everything else has gone, it shouldn't. But you never know. So on the stool over here, I have an Arduino sketch. So that sketch is in C. And it's a sample sketch for a sensor that detects gestures and ambient RGB colors. So light, the color of light that's shined on it. Now I really want to use this in JavaScript, right? Now I could, and one way I have gone about doing this in the past is reading through pages and pages of C code and writing things down, and about 2 years later I'll have a semblance of it working. But luckily now I have tools to help me, and one of them is the Analog Discovery 2. So a lot of wires coming out of here. This is one of the best inventions ever. If you are very much into robotics, it's worth the investment. It is $300, but it's an oscilloscope, a logic analyzer, a waveform generator. It's all of the tools that normally go in an electronics tool bench in one. So if you have no tools, It's cheaper than buying all of the tools. It's also much more portable. Now here's the really cool part. They recently added a scripting functionality, and they decided to make the scripting language JavaScript, which to me is pretty great. So I'm going to open a workspace real quick that I created. No, I don't want to save this one. No. Code. There we go. And 82. And okay. So first I'm going to show you, I'm going to pull out some wires because I'm going to need to connect them. So the way a logic analyzer works is you plug it into the device that is running, and then it basically watches the signals go by, and then it translates those signals into code that we can understand. In this case, I²C. So I²C speaks in hexadecimal bytes. That's really all you need to know to understand this demonstration. So the way I have it set up is I'm going to plug these two wires. And this one's going to go to SCL, which stands for clock, because clock is how it understands what the device is trying to say, like it's a timing thing, so that they're synced up, and then the other goes into data. And I'm going to set this here. Stay. I talk to my robots a lot more than you think. So first I'm going to show you what it's like without JavaScript. I'm going to record. Yeah. Oh, ground. I forgot to ground it. When in doubt, you're missing a ground wire. My one complaint about this form factor is trying to find the exact wire you're looking for is not always the easiest, even if they are color-coded. There's my ground. All right, let's try that again. Good. That's interesting. Oh, ha ha ha. Okay, that's why. Reset that. Anyway, luckily, this doesn't affect the demo all that much. So normally what would happen here is you would see a bunch of hexadecimal values that I would then stare at for an hour and think, okay, how am I supposed to parse this into this instruction followed by this instruction followed by this instruction? Luckily, I can program that in JavaScript. So I have a script here, and here, let me move the window over. So, no, thank you, hot corners. Logic 1, run, and then I have a line variable. And then for every event that happens, so every piece of hexadecimal data, I kind of do some filtering here. I don't really care about the start event except to say I want to show starts. And then when it says stop, that means the command is complete. So instead of having to look at the list and go from start to stop and then look at all of the things in a vertical line, I can now format it into a single line where it's got start, address, command, command, stop. Start, address, command, command, stop. So I get like a nice formatted file of data. And so I'm going to run this. One last idea here. I'm going to unplug these and then run it. Sometimes it's a little finicky about being watched. I know I don't like being watched. Okay. Reboot. This goes here. Yes, yes. I'm probably being really good on the translator by not talking a ton. All right, I'm going to run it. Now it runs it for me. I don't have to go back into the logic analyzer in order to do that. Now you'll see in the link there, file, code, talks, node conf, 82, data.txt. So let's go to there in the Finder. Stop. Node conf Argentina. Okay, so, so you can see, it's a little pixelated. Let me try to make it bigger. Start, H39 is the address, WR means write, ACK means that it acknowledges, the sensor acknowledges that there's an event going on, and then H94 is the value that's being written, ACK start. It's H39, RD, ACK. So read, I can see all the writes and all the reads in order. Instead of having to look at that list and go, okay, that's a read, and then there's the address, and then there's this. Especially because in the raw data from the logic analyzer, repeat events happen. My script filters out repeat events so that I only see, so if I want to turn this into Node, I now have a recipe for the commands that I need to send the sensor in Node from the C program instead of having to read the C program. Thank goodness. I don't mind reading C, and especially with SparkFun and Adafruit, they do a really good job of commenting their code, but this is way easier. Now, one last thought on tooling. If you're not ready to make a $300 investment, I don't blame you. But if you do want to make an investment in a tool, this is called a Bus Pirate. You can buy them off Seed Studio internationally, and if you are in the US for some reason, or SparkFun might ship to South America, they sell at SparkFun. They are $30, and they do just about everything that that $300 tool does at lower performance. But for Arduino hobbyists, this is plenty. And this will also replace a lot of tools that you will need. It can function as a rudimentary oscilloscope. It does do logic analysis. It does sniffing, so it watches traffic and then prints it out for you. And there is an NPM package to control it with Node. I wrote it, and I need more pull requests because I only have about half the functionality done. So if you do get one, let me know. I'll help you get started running it with Node. Now, let's get back to the content and wrap up, because I am most certainly running over time at this point. Out of the library to the social area. Now, this is actually the most important part, and that's kind of why I made the scenery a little bit minimalistic, let's call it. The social room is where the most impact is made and where the most important work is done. I actually did the demo that I mentioned here, and so this is one of my trademark speeches. There's nothing more important to robotics, to development, or to anything than how we treat other people, all people. My only goal in NodeBots is to show you, yes, you, and you, and you, and I can't really see you because of the lights, but all of you, that this power and this magic and this stuff that I'm doing up here is absolutely within your grasp. And that power is yours just as much as it is mine, just as much as it is anyone's. No matter your race, identification, status, this power that computing gives us is yours to grasp. Your ideas to build something are not silly. You are smart enough to build a robot. You can do this, just as I can. I didn't know anything about robotics 3 years ago, and I'm here now. I wear light-up clothing to events sometimes. I build things because it's a power that we all have, because we all share that knowledge. Open source is the key to everything. Open source in code, open source in knowledge, open source in people. In this day-to-day slog, it can seem hopeless, and it can seem like hate and anger and discrimination have won, especially if you live in the United States right now. But I choose to don the avatar of a warrior this day, to show you that this is your fight too, and it is your right. You have every right to be here. You have every right to build things. You have every right to be proud of what you built. You have the right to know what your work is worth, and you have the right to work in an environment that is safe and that is good to everyone. And you will not only have the right to be in that environment, but you have the authority and the obligation to help maintain that environment. Be welcoming to others. You know, if someone's having trouble with a problem, try and help out. Maybe you learn something. If anything I've shown you, or anything another speaker at this conference shows you, amazes you, pursue it. Build something. Doesn't matter if it won't make you money. Doesn't matter if it won't save the world. If it makes you happy, build it. Because you have that power. We all have that power. And then share your knowledge. Share your code. Share your ideas. Ask us for help. Build it. And be the one up here next time. You know, I'd like to see other speakers. I love seeing new speakers and things they bring and the ideas they bring. The more ideas we have, the better the community gets. End of statement. Thank you very much for listening to my presentation. My email is cass@iopipe.com. I am NodeBotanist on Twitter. I will be setting up at a table somewhere, likely outside the auditorium with my bots. I'll get the social bot working, even if I have to yell at it. And so feel free to come stop by and see it working. And any of my other demos, if you'd like a demonstration of like the bus pirate or anything that I didn't really have time to get to in this talk, just come talk to me. Even if I'm hacking on something, just feel free to interrupt me. I am here to answer your questions, and thank you very much.